Station 6 starts with this flashlight. Now this flashlight doesn't have a battery in it and is a hand-operated emergency flashlight. Now you can see there's a paper clip stuck to it, and that's because on the inside there is this magnet that slides back and forth. So there's a magnet on the inside that moves back and forth freely. And that magnet moves in and out of its coiled copper wire. Now we've seen that an electric current through a coil of wire will generate a magnetic field. But what if a magnetic field is moving around a coil of wire? Well, that creates electricity. So as we shake this magnet back and forth, the flashlight will get brighter. So, moving a magnet or alternating a magnetic field within a coil of wire will induce an electric current. This is what we call a generator. That moving magnetic field converts mechanical or kinetic energy into electricity because of the interaction between the magnetic field and the coil of wire. Now this is a very simple demonstration, but not very useful in generating much electricity. Now we can make a simple generator using an electric motor. Here I've got a Connex hand crank built. The green piece here is an electric motor. You can see we can plug it into something. Then I've got a series of gears to transform the mechanical energy of cranking this into electricity. Now this device here is called a voltmeter, and as voltage is pushed through it, it will move the gauge and show us how much electricity is being created. So if I plug that into the motor, as I spin the little coil of wire that's inside that permanent magnet of the motor, we should see voltage appear. And if I stop spinning, the voltmeter goes back to 0. And what happens if I spin it really fast? We can generate much more electricity. Now we're generating about 2.5 volts, which isn't very much. Remember that a regular battery only has 1.5 volts. Okay, but this shows that the property of a motor, where electricity flowing through the motor creates motion, can be reversed. So motion, causing the motor now to be a generator, generates electricity. As a coil of wire is spun around in the inside of a magnetic field, now we're creating electricity. Now if we unplug this and plug this green motor into this capacitor piece, the capacitor acts like a battery, this other little piece here. It stores energy. It's a very simple way to show how we might be able to store some of the electricity. So if I spin up the generator, as it spins, it's going to be creating electricity, which is going to go into the gray capacitor. If I do this long enough, now when I stop, the capacitor takes over and starts running the motor. So electricity was flowing from the motor into the capacitor, being stored there, and then when I stopped, it started flowing the opposite way, back into the motor, creating mechanical energy. Unfortunately, it's not a very efficient system. You can see it's already slowing down. It doesn't run for nearly as long as I spun it, nor as fast as I spun it. This is the problem with electricity generation today, is that we can generate electricity pretty easily, but there's no real efficient way of storing that electricity for any long amount of time. But we are getting better at it. So using what we've learned in this section of the lab. Moving or alternating a coil of wire within a magnetic field will induce an electric current, just like moving a magnetic field through the coil of wire will induce an electric current.